Okay, so all right, let's continue with the recursion discussion. So we have seen linear search before, if you remember. So what does a linear search do? Basically, if you have an array, right? Let's say you're searching in an integer array, and there are certain numbers 5, 1, 12, 6, 3, 7, 8, and 5. And you're trying to find, let's say, 3 within this list using a linear search. So in the linear search, if you recall, how does linear search work? How does the linear search work? So you scan it from the first element all the way to the end, or you could do a reverse, scan if you like. Doesn't matter. However, what you do is you basically compare one element with the key that you're searching, and then continue with the next one, and further on continue in the process until you find the result. So let's say if I'd like to write the method in an iterative fashion, how would I write it? I will return an integer which indicates the position where I found the key. So I will have public int, let's say linear search, and then I will have an integer array, right? Let's say I have A, and then I'm going to search for int key. So if you wanna write this, normally how would you write it in an iterative fashion? For, right? Basically you will I0, you'll start from the first element, and then you'll continue all the way to the end by checking a dot length, right? So I'll go all the way to the end of the list, and then I'm going to increment my I by 1 every time. So I will check whether the current element is equal to key, right? If key is equal to AI, since I is my iterator, it's going to start with the first element, compare it with the key. If not, it will continue on and on. If key is equal to AI, what am I going to do? Return I, the position where I found the key in the array. And then this is going to go on and on until the end of the list, and that will do it. Is it? Is it sufficient to leave it like this?
Hocam iyi bulduğumuz zaman mesela i eşittir a'da length deseniz direkt buradan çıksanız. Olur mu öyle bir şey?
If I find it, it will exit anyway. Because return is going to tell me that, hey, once you find it, just finish it. The whole for loop is going to finish, and the method is going to be finished as well. Let's say if it finds it in the first element, that's the feature of return. Return tells you, hey, return the result. It will return the overall result of the method immediately, even if it finds in the first entry. So it's not going to continue with I plus 1, 2, 3, and so on. But it is not sufficient, right, in this way. If I cannot find it in the list, what's going to happen? So it will come here, and then, so what? What are you going to return? You have to return an int. So basically you can return something that is not meaningful in terms of the linear search, which could be -1, which does not exist in the array, right? So there's no array element that's -1. So you'll just return -1 here, because the array's length is going to be from 0 to length -1. So it should be, if a reasonable result is going to be returned, then it should be between 0 and length -1. Again, pay attention to return. Whenever you say return, it is going to finish immediately. The whole method is going to finish immediately after this statement. If you execute this, then it's not going to continue to search for the next element and so on. Okay, so this is the iterative version. What if you wanted to write a recursive one? So basically whatever is the first one is going to be returned. That's a good question. So let's say in this case we have 2 5s and I'm looking for 5. So it will check for 9. It's not equal. It will go into the second iteration of the 4. It will compare it with 5. It will say, hey, I found it. If key is equal to AI, will return true. And it will come to return I, which is basically going to return 1 as a result, since it is the position of 5. So it's not going to go all the way to the end and check and find that one too. However, if you want to do that, if you want to return the last one, how can you modify this? Yeah, exactly. If you start from reverse, you will return the last entry, which could be just, I equals a dot length minus 1, and then I is greater than or equal to. So if you do it reverse, a dot length minus 1, and then you go from here to all the way to I is greater than or equal to 0. I minus minus is going to decrement the I value every time. So this is going to start searching from the end of the array. Okay. So if I want to convert this to a recursive linear search, how am I going to search? So it's going to be returning the same exact thing. But how are you going to search in this array now?
Firstly, we have to compare with first element of array, and after that we have to make smaller kısaltacağız şeyi. Ve geri kalanı da aynı metodoloji uyguluyoruz.
So how am I going to write? Tell me. If int a0 is equal to key return 0, else so what's missing here? There is nothing like reducing the array. If you create a new array and copy all entries from here to there and then make it a new array and it has a smaller length, then you make a smaller sized array. That you can do. But there's not single statement that tells you, hey, make it smaller from the left hand side or right hand side. You can't do that. You have to do it manually. So basically what's missing here is another parameter which you need to add. What do you need to add? Start or index, whatever you call. So you'll have a third parameter which basically enables you to do the recursion. Okay? So in this case, I will modify my if a0 is equal to key to something else. What is it going to be? A index is equal to key. Return index. So if I find it in the current index that I am looking for, I'm looking in, then I will return that index. Otherwise, what I will return? I will return linear search, and then I will say the same array, right? array doesn't change. And then I will say key is same. What's going to change? It's going to be just incremented, it's just going to increment the index by 1. Or if you are going to start from the reverse, you'll just decrease the index by 1 every time.
Hocam o indeksin 0 olduğunu bilmiyoruz. 5 derse adam indeksi. O zaman 5'ten başlamış. 5'ten aramaya başlayacağım.
So whenever you call it first time, what are you going to use to call the linear search? Let's say I have an array called linear search. Let's say I have array called list. And I will be looking for 4 in this. I will start it from 0. For the initial call, you are going to write 0. If I said, as I said earlier in the previous lecture, you can write another method which overloads this. Remember, we were writing another method. You could write this public int linear search, and I'm overloading the name linear search by another method int a int key, such that I call this method with linear search, and then I give the same array key and 0. And further on, if you make this private, user will never know that this is a recursive method which is called by this, and it is basically doing it recursively. Okay. However, is there any problem with this recursive method here? What's the problem? So, when are you going to stop? If you cannot find it, is it going to stop? So you're not done with the base cases. Yes, you will get out of bounds exception, right? Array index out of bounds exception, because once you reach the last entry and you still try to search it with the next element which does not exist here, you're going to get index out of bounds exception. So how can you correct the problem? Basically, you need to have a check that says, hey, you have reached the last element with this index. So that's going to be the last element you're checking. So you have to do that. Either you can have another if here, which does that before this if, right? So that if index is equal to, length, blah, 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 you can say that. So if index is equal to a dot length minus 1. No? If index is equal to a dot length minus 1, return, when I reach the last entry, return minus 1. You'll just need to switch these two ifs. If AI is equal to key, return, you can write it that way too. Return I, right? Not I, index. Index is equal to k, return index as if, is it correct now? As if index is equal to a dot length minus 1, return minus 1. You have reached to the end of the list and you haven't found it yet. Index is equal to the array size. If you find it, this is going to return it. Return the last index. If you couldn't find and it is the last entry, then you have searched all the entries and you'll need to exit the method. Okay? So let's do binary search now. How does binary search work? In binary search, if you remember, you have a list that is already sorted. So you have a list that says 1, 3, 6, 9, 12, 15, and let's say 21. This is already sorted. A sorted list is given to the binary search. So I will just modify this to make it public int. Again, returns me the index of the element that's where it's found. So I will have int a, int key, and then I will modify the arguments here in binary search, because in binary search the method is how you have a starting point and then end. How does the binary search work? Basically, I will get the mid element by computing the indexes of mid. Mid is equal to, right, start plus end divided by 2. So in this case, it's going to give me this element. That's going to be my mid. Then what do? I compare my key with the mid. If key is greater than the medium, I will go with this part. If it is less, I will go with this part. I know that it definitely is going to be on this part if it is less than the medium. So basically, to enable this call, this method execution, you need to have in your method call in binary search, you have to have a int start index, which tells you where to start for searching in binary search, and then where to end. Okay? And if in my binary search, what am I going to do next? Basically, one thing to check is in binary search, as you see, once let's say I'm looking for 4 in this list. Obviously, it doesn't exist. So how are we going to find it? I will compare with my mid is going to be, what is it, mid? This is 0, this is 1, 2, and then 3, right? So my mid is 3. I compare the mid element, the 9, the third element, with the key which is 4, and in that case it falls into the left hand side. So my new start is going to be same as before. Start is going to be 0. My end is going to be mid minus 1, the previous entry, which is going to be this second entry, right? So when I calculate my new mid is going to be 0 plus 2 divided by 2 equals 1. So my mid is pointing here, and then my new end is going to be pointing here, right? So I update my start and end every time with the new binary search call. And what am I going to do? I will compare this mid by my key, 3 and 4, so it falls onto the right hand side. What's going to happen? I will make my new start as, what's it going to be? My start is going to be mid plus 1. Mid plus 1, so it's going to be 2. And then my end is going to be same as before, it's 2. Right? So as you see, I will stop whenever my end is either equal or greater than the start. If you have odd number of things, this could also happen. End could be greater than the start. So this is the stopping condition for your iterations in the binary search. If you reach that, that means it doesn't exist, because your end and start, you start with this, and then every time each one moves towards each other. And then at a certain point, if you have something like this, that means you exhausted all the options and you no longer have an option to search within the array. So basically, you are going to return -1 in this case. So sorry, start is greater than or equal to end. Thanks. So if start is, in terms of index value, if start is beyond the end, that means you're exhausted all the options. So the basic thing is going to be if start is greater than or equal to end, you have searched all the entries so far and you'll return -1. Else, or maybe you don't need else, you can first calculate mid by start plus end divided by 2, so you get the medium element. Now what you do, if my key is greater than mid, or let's check first for equality, if key is equal to mid, what am I going to do? Return mid. Sorry, this is going to be key is equal to a mid. Return mid. Else, if key is greater than a mid, then what will I say? I will say return binary search. Again, I will have the A and then I will have the key. And since, what did we say? Key is greater than the medium element. So this is medium. This is my key and my value is within this region. So I will update my start to be here. Right? And I will say, I will call it with the start, which is going to be the mid value. So A, key, mid, and then end. Sorry, mid plus 1. Okay? Now, I know that it is not equal to mid and it's not on the left hand side of this, so it must be from here all the way to the end, which is mid plus 1 to the end. So I will search the same thing with that. Else if a key is less than, right, this is the last option, less than a min, then I will say, I will call return, no, not return, sorry, binary search. Binary search or no, it's return, right? It returns an integer, sorry. Yeah. Return binary search a key. However, this time I know that it's on the left hand side, which is going to make it this one mid minus 1. And my start is going to be same as before. So a key and then start and then mid minus 1. So as you see, you call in a recursive fashion over and over the binary search algorithm until either you are exhausted all the options, you don't have anything to search for anymore and you couldn't find it, or you found it in the mid element. That's where you're going to stop. So every time when you call this with the start mid minus 1, whenever start and mid is equal to each other, and then next time when you call start with mid minus 1, that's when it is going to happen. See, if the start and mid are equal to each other, and then you call this with start and mid minus 1, in the next call within that it is going to be less than the other one. Okay? So I will stop here. You will have a review from this point on, so please fill those forms and answer the questions. I will be leaving momentarily. So see you.